6.2, calculating the hypotenuse. So in the last lesson, we learned an easy way to estimate the length of the longest side of a right triangle. In this lesson, we're going to learn how to actually calculate it. But first, we're going to review some basic ideas. So this is some of the arithmetic that we're going to be using when solving for the hypotenuse. So the first thing that we have to remember how to do is to square a number. So square a number, that's when we see the little exponent of 2 up above the number, means to multiply that number by itself. So for example, 3 squared is just 3 times 3, which is 9. Be careful, a lot of people make the mistake of squaring a number by multiplying it by 2. I have a lot of people that tell me that 3 squared is 6, but it's not. So 3 squared is 3 times 3. We're multiplying a number by itself. The opposite of squaring a number, so it's the reverse operation, is finding the square root. And you can see a square root by this little symbol right here. And taking the square root means you're finding out which number is multiplied by itself to give you a specific value. Basically, you're doing the opposite of squaring. So if I take the square root of 9, I want to find out what number I can multiply by itself to get 9. And I know that 9 is 3 times 3. So the square root of 9 is 3. So just like 3 squared is 9, that's one direction. I can go in the other direction and say the square root of 9 is 3. So because those are opposite operations, I can combine them to do something called eliminating the square. So for example, if I have that some value c squared equals 16, but I want to know what c by itself equals, I can do what we call eliminating that square. I can get rid of that little 2 exponent that is on the c. To do that, I take the square root of both sides of the equation. So I have c squared equals 16. I take the square root of both sides of the equation. You see over here, I have the square root of c squared. And because those are opposite operations, they actually cancel each other out. So the square root goes away, the squared goes away, and I'm left with just c down here. So opposite operations cancel each other out. So for example, if I add a number and then subtract it again, because adding and subtracting are opposite operations. So for example, 6, if I add 2 to it and then I subtract 2, they're opposite operations, so they're going to cancel each other out. And 6 plus 2 is 8. Take away 2 is 6 again. So opposite operations cancel each other out. Multiply and divide are opposite operations. So if I have 10 and I multiply by 3 and then I divide by 3, well, 10 times 3 is 30, divided by 3 is 10. So again, those opposite operations cancel each other out. Well, the same thing with squaring and square root. So if I have a square, I can take the square root and they'll cancel each other out. But here's the thing, when I have an expression with an equal sign in it, I can't just throw a square root on one side of it. I have to keep that expression balanced. So what balanced means is whatever I put on one side of the equation, I have to put it on the other side as well. So because I put square root on the left side of the equation, I have to put it on the right side as well. So c squared equals 16 becomes the square root of c squared equals the square root of 16, which tells me that c equals, and the square root of 16 is 4. Okay? So the big takeaway I want you to get from that is if I have a letter, a variable squared equals some value, and I just want to know what that variable is without the squared, without the exponent, I can take the square root of both sides. So let's try a few problems as far as squaring and square root goes. So A, 2 squared, so that's the same as 2 times 2, which is 4. Now I have a couple of A's here, so we're going to go through each one. So the second A across is the square root of 25. So what I want to know is what number can I multiply by itself to get 25, or what number squared would give me 25, and that number is 5. And then the last one in this row, the last A, is c squared equals 9. So I want to know what just c equals. To do that, to get c by itself, we have to eliminate the square, which means we take the square root of both sides. So I take the square root of c squared, so they'll cancel each other out, and we'll be left with c. And I take the square root of 9, and we get 3. So if c squared equals 9, then just c by itself will equal 3. So I want you to take a second and just try the row of b's. Don't go to the c's yet, just try the row of b's. Okay, so 4 squared would just be 4 times 4, which would be 16. The square root of 4, so I want to know what number do I multiply by itself to get 4, or what number can I square to get 4. And I know that 4 is 2 times 2, so the square root of 4 is 2. And finally, c squared equals 49, so just like above, we're going to eliminate the square, so we take the square root of both sides. On the left side there, the square root and the square are going to cancel each other out. I'm going to be left with c. And the square root of 49, well, what number can I multiply by itself to get 49? And that would be 7. Okay, and the row of c, so 5 squared would be 5 times 5, or 25. And then we get to the square root of 20, and this is where it gets challenging. Because as much as you can think and think and think, you're probably not going to be able to come up with a number that multiplies by itself to give you 20. Because 4 multiplied by itself would give you 16. 5 multiplied by itself would give you 25. So it's somewhere between 4 and 5. But you're probably not going to be able to come up with that number on your own. So at that point, we are going to have to put our square roots in our calculator. So every calculator is a little bit different. So your square root button usually looks like this. It may have the line across the top, but this is usually what it looks like. Some calculators, you would press the square root button and then you would put the number in. Other calculators, you would put the number in first and then press the square root button. So try the problem in your calculator and see which one works. So we're looking for the square root of 20. So mine, I press the square root button. No, sorry, see? You have to check and see. So mine, I have to put in the number 20, and then I'm going to hit the square root button. And you can see up there, it's plugged in the square root of 20 for me, and I get 4.47. So the square root of 20 is 4.47. So make sure you try in your calculator and you see how you enter yours in. If you're not sure, let me know and I can come and give you a hand with that. Okay. And c squared equals 15. So again, we have to eliminate the square here. So we end up with the square root of c squared equals the square root of 15. And 15 is another one of those numbers, as much as you rack your brain, you're probably not going to come up with a number that would multiply by itself to give you 15. I could come up with a number that multiplies it by itself to give me 16, and that would be 4, but it's not 15. So it's going to be a little less than 4. So we're going to put in our calculator 16, and we're going to hit our square root button. 15. And hit our square root button, and we get 3.87. So C in this case equals 3.87. Okay, so those are just some arithmetic skills that we're going to use to actually solve for the hypotenuse in a right triangle. Okay, so how do we find the missing hypotenuse of a right triangle? So we use an equation that I'm sure you've heard of before called the Pythagorean theorem. Pythagorean theorem states that a squared plus b squared equals c squared, and that's a formula that you will always get on your formula sheets. You won't have to memorize that. So the important thing to note here is that in a squared plus b squared equals c squared, c will always be the hypotenuse. So a and b are the legs, and it doesn't matter which leg goes with which letter, but c always has to be the hypotenuse. So let's look at an example, and we're going to use the table below to help follow the steps to solve the triangle. So we're going to find the length of the following triangle. So you can see that this triangle, the length of the hypotenuse, you can see this triangle has a leg of 4 and a leg of 3. We need to find the length of the hypotenuse. So here are the steps. First step is always to write down the Pythagorean theorem. A squared plus b squared equals c squared. Okay? The next step is to fill in the legs for a and b. So I'm going to take out the letter a, and instead I'm going to replace it with one of the legs. It doesn't matter which one. I'm going to start with 3. So we get 3 squared instead of a squared. And we're going to fill the other leg in for the other letter. So instead of b squared, we're going to have 4 squared. And c is our hypotenuse. We don't know what it is. We will leave it c. My next step is to square both numbers. So 3 squared is 3 times 3, or 9. 4 squared is 4 times 4, or 16. Then I can add those two numbers. So 9 plus 16 is 25. And now I have 25 equals c squared. And the great thing about that is the skill I just learned called eliminating the square, where I take the square root of both sides of the expression, and that will tell me what c equals by itself, because that's what I want to know. My hypotenuse up here, that's c, and I want to know the length of it. So all I have to do is take the square root of 25, and the square root of 25 is 5. So the length of the hypotenuse is 5. So now I want you to take a second and try this. So find the length of the hypotenuse in the following triangle. So follow the same steps that are up here. Write your expression, fill in your legs, square both numbers, add them, eliminate the square. Follow those same steps and try to find the length of the hypotenuse for this triangle. Okay, let's have a look. So our first step is always to write the Pythagorean theorem. A squared plus b squared equals c squared. Then my next step is to fill in the legs. So I'm going to fill in 6 and 7 for a and b. So 6 squared, and my next step is to square the numbers. So 6 squared is 36. 7 squared is 49. Okay. Then I add my numbers together. And I should get 70, 79, 85. And then my last step is to eliminate the square. So I take the square root of both sides, and that will tell me what c equals. And 85 is another one of those numbers where no matter how hard I think, I'll never come up with a number that multiplies by itself to get 85. So I need to use my calculator. So I'm going to put in 85, and then I'm going to take the square root, and I get 9.2. So the length of my hypotenuse in this case is 9.2. Okay? So what I would recommend is when you start solving these problems, when you're working on the practice problems, start by following these steps. Reading them along, having this page next to you, going step from step from step. But you should, by the end of the practice problems, get very comfortable with just looking up the formula and writing it down and knowing the process on your own. So give some of the practice problems a try and see how you do.